Dear student, I, Professor Prasant Bua, Dr. Subhash Technical Campus, Junagadh. Today's in this session, we'll discuss one sole example of welded connection. So, in previous welded connection section, we have described the types of welded joints are used, types of welding connection, which are the close and welding properties are given in IS 800 2007. So today in this video we will start to solve one example to identify the design of suitable welded joint. So the data of example is, as per your screen you can see that an ISA 125 by 95 by 10 carries a factor tensile force of 420 kilonewton and it is connected by its longer leg to 8 mm thick gusset plate. Design a suitable welded joint using first condition 6 mm fillet weld on toe and heel. Second one is 6 mm fillet weld on toe, heel and at the end also. And third condition 6 mm fillet weld on toe and 8 mm fillet weld at heel at the end. So as per the data is given, it's a combination of three different example, but I'll cover in this one example so we can identify these three different condition. So first step, you can see first of all the figure. We can see the types of plate is given to you and we transfer the tensile force of 420 kilonewton. So in first case, our first condition of exam, 6 mm fillet weld on toe and heel. It means we provide the welded at toe and heel. So two force are acting according to figure. PU1 and PU2 be the force acting on a toe and heel respectively. So P is acting at a centroid of angle is C. This is the P, and that CXX is given according to your steel table 38.9 is nothing but your CXS, center of acting centroid of angle. So it's simultaneously bottom to P is 38.9. So it will be the act as a P force. So taking moment about heel. Now we take the moment about heel. So PU1 is equal to 420. It means our P 420 multiplied by 38.9 divided by 125. 125 is our size of plate or angle. So PU1 we calculate 130.7 kilonewton. So total load we transfer or we resist 420. So PU2 is equal to total P minus PU1. It means PU2 is 289.3. So in our first step we calculate PU1, PU2 force acting on toe and heel respectively. Our next step, to decide the size of weld at toe and heel. So the minimum size according to 6 mm fillet is given. So 3 mm. So S max is equal to 3 by 4th 10 is equal to 7.5 mm. Therefore we can use 6 mm. But in our data already 6 mm fillet weld is described. If not described, then you can find out with the codal provision of minimum and maximum size of weld. After deciding the size of weld is S is equal to 6 mm, we can calculate throat thickness. Throat thickness is 0.7 times S. It means our throat thickness is 4.2 mm. Now strength of weld FWD, it means FWN by gamma partial safety factor. So our FU is 410 under root 3. It means our FWN is 236 MPa. So therefore FWD is equal to 236 divided by 125 for soft welding. So our strength of weld is equal to 189 Newton per mm square. Next step, 6 mm fillet weld on toe and heel. So now we provide the welding at toe and heel. So the strength of weld per length So FWD multiply by throat thickness. So FWD we calculate 189 and throat thickness we calculate 4.2 mm. So this FWD is Newton per mm square and 4.2 is mm. So finally we got strength of weld per mm length 795 Newton per mm. It means we provide 1 mm weld, then it resists 795 Newton. So the length of weld required on heel and toe. Now we decide the length of required at heel and toe. So the length of required first of all on heel. So you can see that figure in heel PU2 is connected and in toe PU1 is connection. So when we require to find out the length of weld on heel, PU2 divided by strength of weld per mm length. So PU2 you can see that 28930 divided by 795. It means 363 mm. We can say 370 mm length are required. Same as a toe. PU1 divided by strength of weld per mm length. So strength of weld per mm length 795 and PU1 is converted into the Newton. So Newton cancel out and we got finally answer in mm. It means length of weld. So as a toe we can calculate 165 mm. We convert into the round figure. So you can say 170 mm length. So in our first case we provide in heel 370 mm and at toe 170 mm. Also provide end returns if data is given then. So end returns to provide 2 times S. So this arrangement in toe and heel providing the welding, it should be resist total P 420 kilo Newton. Our next case 6 mm fillet weld on toe, heel and end. Now we can welding at toe, heel and side also. So there are the three force PU1, PU2 and PU3 with the force acting on toe, heel and end. It means PU1 is acting on a toe, PU2 is acting on a heel and PU3 is acting on a side. You can see this figure PU1, PU2 and PU3. Now P is acting at centroid of angle that will be shown in our first case. It should be act as a CXX. So CXX value is given according to your steel table 38.9 mm. So since we can according to the size of weld or you can say the plate used for the welding is minimum size is 3 mm and maximum size is 7.5. Therefore we can use 6 mm weld. Also the 6 mm weld is given in our data. So next step we find out throat thickness. So throat thickness is 0.7 times S, it means 4.2 mm. Then we find out strength of weld FWD. So for FWD first we find out FWN, it means FU under root 3. So 236 MPa. So finally we got FWD FWN divided by gamma M partial safety factor. So finally FWD is 189 Newton per mm square or you can say MPa. So now first we calculate PU3. Why PU3? Because we know the length of PU3 it's same as the size of our plate. It means 125. So PU3 is equal to FWD into 0.7 into S into LW. Here FWD is 189, throat thickness is 4.2 and our length of weld is 125. So finally we got first value out of these three forces PU3 and it should be 99225 Newton. It means 99.22 kilonewton. Now taking the force about heel. So we get another PU1. So 420 our P multiply by CXX 38.9 minus the another force PU3, it means 99.22 multiply by 125 by 2. It should be act as a centroid of 125 and divide by 125. So PU1 is directly we find out 81.1. So we know the two value of PU3 and PU1. So we directly find out PU2 total force divided by PU1 and PU3. So PU2 is calculate 239.7 kilonewton. Now this force we can distribute it on toe, heel and end. So now it's depend on the length of weld provided. So first we calculate the strength of weld per mm length. So the strength of weld per mm length is equal to FWD multiplied by throat thickness. So finally we calculate 795 Newton per mm. Now first length of weld required on heel. First we calculate length of required on heel. Already and we calculate it should be provided 125. So PU2 divided by strength of weld per mm length. So we got 302 mm. So converted into the round figure 310 mm provide the length in a heel. The next we require the length of weld on toe. So again PU1 is force acting on a toe. So PU1 we calculate 81.10 kilonewton converted into the Newton. So divide by strength of weld per mm length 102 converted into the round figure 110 mm. So in this step we can provide the weld on toe, heel and at the end. Our third condition, or you can say the third criteria of example, 6 mm fillet weld on toe and 8 mm on heel. Now both the size of weld are different. So again three force are acting on toe, heel and end. It is PU1, PU2 and PU3. P it is acting on centroid angle of section 38.9. Now on heel and toe S is equal to 8 mm. So the throat thickness is 0.7 times 8. It means 5.6. Here throat thickness is different. So strength of weld is same we calculate in our first two condition. It should be 189 MPa. So now we calculate PU3 because we know the length of weld of PU3 it's nothing but 125. So PU3 FWD into 0.7 times L into LW. So PU3 is calculate 132.3 kilo Newton. Now taking moment of force about heel. Now we take the moment at heel. So P into 38.9 minus 132.3 into 125 by 2. It means centroid of 125 divided by total length 125. So PU1 we calculate 64.4 kilo Newton. After calculating the PU3 and PU1, we directly got PU2 total force minus PU3 and PU1. So PU2 is calculated 223.1 kilo Newton. Now same as the previous two step. Now next we calculate strength of weld per mm length. It means FWD multiplied by throat thickness. So we got the strength of weld per length. It means 1058 Newton per mm. So length of weld required on heel. First we calculate length of weld required on heel. PU2 divided by length of weld per mm. So PU2 you can see in our calculation 223.1 kilonewton converted into the Newton. So the answer should be find out in mm. It's 211 mm converted into the round figure. So finally 220 mm length is required on heel. Next we find out the length of weld required on toe. So again strength of weld we calculate. So here the throat thickness should be changed. So the strength of weld is 795. Same way length of weld required on toe is equal to PU1 divided by 795. So we can know the PU1 is 64.6 kilonewton. So we calculate 82 mm. It means say 90 mm. So likewise we calculate toe and heel length and already and we provide 125. So this example are covered into the under three small example that are used, or you can say the calculated in different way of these three conditions, and these example are repeatedly asked in GTU also. Thank you friends.